My name is Danko Emmanuel Kenjo, and I officially welcome you to Tech 96 TV. So in our previous lesson, we talked about physical quantities, where we said a physical quantity is any quantity that can be observed and measured. We also talked about the two types of physical quantities, being it fundamental quantity and derived quantities. Then we also said we have 7 fundamental quantities, and anytime we combine 2 or more of the fundamental quantities, we obtain what we call the derived quantity. So for today's lesson, we are moving on to what we call dimensional analysis. And when we talk of dimensional analysis, it's the study of relationship between physical quantities with the help of dimensions and units of measurement. So the study of relationship between physical quantities. Remember, we said physical quantities can be grouped into 2, fundamental and derived quantities. So when we talk of dimensional analysis, we are trying to study the relationship between those quantities, being it fundamental or derived quantities, with the help of, so we are going to use what we call dimensions and units of measurement to establish that relationship. And when we talk of units, each quantity is assigned to a particular unit. So when we talk of, let's say, density. So density is a derived unit because it's a combination of mass and volume. And remember, volume is also length times length times length. So when you talk of density, we are trying to combine mass and length to obtain what we call density. So density is a derived quantity. Then mass is a fundamental quantity. So when you talk of dimensional analysis, the study of the relationship between fundamental quantities with the help of dimensions and units. And the unit of density is kilogram per meter cube, or kilogram per meter cube. So per this unit, we can use these units to establish a relationship between the physical quantities. So now let's quickly talk about the uses of dimensional analysis. 1. Dimensional analysis helps us to find the unit of quantities. So if I know the dimension of a particular quantity, I can use that dimension to find the unit. For example, the dimension of velocity is LT minus 1. Now, the unit for length, because this L here represents length, and the unit of length is in meters. This T is time, and the unit of time is seconds. So with the help of dimensions, I can be able to find the unit of a particular quantity. So if I know that L is in meters, T is in seconds, then it means that the unit for velocity is meter per second. So anytime I know the dimension of a particular quantity, with the help of the dimension, I'll be able to calculate the unit. For example, if acceleration is let's say LT minus 2, and here the L is length, and length, the unit of length is in meters. T is time, and the unit of time is seconds, which is x minus 2. So here the dimension for acceleration is LT minus 2, and the unit is meter per second square, which is for acceleration. We can also use dimensional analysis to check the validity of an equation. So if I have an equation and I want to check the validity, whether the equation is valid or not, or in other words, to check whether an equation is true or false, we can also use dimensional analysis to derive an equation between quantities. So if I have an equation and I want to derive an equation between the quantities, I can also use what we call dimensional analysis. So let's dive deep into the uses. So we start with to find unit of quantities. So we want to see how dimensional analysis enables us to find the unit of quantities. When we finish, then we move on to check the validity of an equation. Then finally, we end the lesson with to derive an equation between quantities. Okay, so using dimensional analysis to find unit of quantities. Now, if we have the dimension of a particular quantity, based on the dimension, you should be able to write the units from the dimension given. So here, suppose we have MLT minus 2 is the dimension of a certain quantity. We don't even know the particular quantity they are talking about. And they want us to find the unit of that certain quantity. So once we have been given the dimension as MLT minus 2, with the help of the dimension, we should be able to write the unit of the quantity. So 1, M stands for mass, and the unit of mass is kilogram, kg. L is length, and the unit of length is in meters. T is time, and the unit of time is seconds. So here, with the help of the dimension, we'll be able to write the unit of the quantity. And the unit of the quantity is kgm per second squared. Let's also take another example. Okay, so the next question, the period T. So period is being represented as T of a simple pendulum of length. So the length of the pendulum is L. Is given by the equation T equal to 2 pi root L over J. Find the unit of the quantity J. So now we want to find the unit of this quantity, which is J. Now we've been given the dimension. Remember, dimension of time is T. L, length is what? L. So we want to find the unit based on this dimension. So first of all, what you are supposed to do is to make J the subject of the equation. So if I have T equal to 2 pi root L over J. L over J. I have to make J the subject. So here I'll square this square here just to cancel the root sign. So I'm going to have T squared equal to 4 pi squared L over G. Therefore, G will be equal to 4 pi squared L over T squared. Now, to find the unit, we've been given dimension. Now, the unit of L is in meters. Remember, 4 pi squared is just a figure and is dimensionless. So here, the 4 pi squared has no dimension. So finding the unit, we will eliminate the 4 pi squared. And here, the dimension of L of length is L, and the unit of length is in meters. This is time, dimension is T, and the unit of time is in seconds, so seconds squared. Therefore, G will be equal to M meter per, so M per second squared. So here the unit of J is meter per second squared. So the question is find the unit of the quantity J, and the unit of the quantity J is meter per second squared. Okay, so let's also look at using dimensional analysis to check the validity of an equation. So here we want to use dimensional analysis to determine whether an equation is correct or wrong. So here, if you want to use dimensional analysis to check the validity of an equation, these are the steps that you need to follow. First, remember, any equation has what we call the left-hand side and right-hand side. So let's say if I have y is equal to mx plus c, which is equation of a line. Here, this is the left-hand side, and this becomes the right-hand side. So what you are supposed to do is find the dimension of the left-hand side first. So you find the dimension of the left-hand side. Then the next step is find the dimension of the right-hand side. Then you find the dimension of the right-hand side of the equation. Note, if the dimension of both sides, so after you are done finding the dimensions of the left-hand side and the right-hand side, if they are the same, it means that the equation is valid. Otherwise, the equation is invalid. So here, let's look at this example. Check the validity of the equation S equal to ut plus at squared over 2. So the equation is s equal to ut plus at squared over 2. Then if you want to use dimensional analysis, it said first find the dimension of the left hand side. So we want to find the dimension of s. This s is distance, this u is initial velocity, this is time, and this a is acceleration. So to find the dimension of distance is L. So here the left hand side we just have L. That is it. Then the right hand side we have ut plus at squared. So let's find the dimension of the individual variables. This is initial velocity. So dimension of u or initial velocity is giving us Lt minus 1 because velocity is distance over time. Dimension of t, which is time, is giving us t. Then dimension for acceleration, which is change in velocity with time. So acceleration is Lt minus 2. So the left hand side we have Lt minus 1, which is u, multiplying t plus Lt minus 2 multiplying t squared all over 2. Now any number is raised to the power 1. So here we are going to have just L here. L plus this t, 2 cancels these 2. So here we are also going to have L over 2. So if you want to simplify this, you find the LCM, which is 2. So 1 goes into 2. 2 times L is 2L plus L, which is 3 over 2L. So here this is the right hand side. So at the left hand side we have L. At the right hand side we are having 3 over 2L. But remember, 3 over 2 is just a figure which is dimensionally constant. It's not having any dimension. So here I can say that the left hand side I'll have 3, which is equal to the right hand. The left hand side I'll have just L, which is equal to the right hand side, which is also L. So per dimensional analysis, I can say that this equation is valid because L is also equal to L. So let's move on to the last uses of dimensional analysis, which is to derive an equation from quantities. So using dimensional analysis to derive equations from quantities. So anytime you are given dimensions of quantities, you can derive equations from the dimensions. And anytime you want to do that, there are specific rules that you need to follow. First is the subject of the equation must first be identified. So you need to first identify your subject. The subject depends proportionally on other quantities. So if I have A directly proportional to B and C, it means that my subject here is A. Then B and C are the dependent variables. So here A is the independent variable and B and C are the dependent variables. So first find the independent variable or the subject of the equation must first be identified. So you should write the equation such that you have the dependent variables at the right hand side, the independent variable or the subject at the left hand side. Then step 2, the dependent quantities B and C. So here we are assuming that A is our subject, which is directly proportional to B and C. So here, these dependent variables, step 2, you are supposed to raise it to a certain powers. So here we can use A and B or X and Y. If there is any other variable like the dependent variables being B, C, D, then we can have Z here. So here you have X and Y. So that is the dependent quantities B and C are raised to a certain powers of X and Y. So that is what we have here. Then you need to convert or change the proportionality sign to a constant. So you replace this with a constant. So here we are going to have a, you change this one to equal to sign. And anytime you change the proportionality sign to an equal to sign, you should have what we call a constant. So here we use a constant k, which is dxcy. So that is the proportional sign is removed and is replaced with an equal to sign and a constant, as we have it. Then we solve for the powers x and y. And how do we solve for the powers of x and y? It's by comparing the powers of the left hand side together with the powers of the right hand side of the variable. So let's take one example and go through the steps. Okay, so the question is, the period t of a simple pendulum depends on the length and acceleration g. Use the method of dimension to establish the equation between t, l, and g. So that is the last use of dimensional analysis, of which we said it is used to derive equations from quantities. So here we can have the period, which is t. So let me write. So you see here, so the period t is directly proportional to length, which is L, and g, which is acceleration. So per the rules, this becomes our subject and this becomes the dependent variables. And we said the dependent variables are raised to certain powers. So here we can have t is directly proportional to L, S raised to the power S, G raised to the power Y. Then we have to change the constant of proportionality to an equal to sign and a constant. So the constant is k. So we are going to have t equal to k L raised to the power x, G raised to the power y. So this is what we have here. Then we find the dimensions of the quantities here. So this is t period, which is time. So the dimension of t, which is time here, is t. Dimension of length, which is L here, is length. Dimension of g, which is acceleration, is Lt minus 2. So here we are going to have t equal to k Lx L t minus 2 y. So y is going to multiply this term. So we are going to have t equal to k Ls Ly t raised to the power minus 2y. Then this is LL. So indices, the base are the same. So we just have to add the exponent. So t is equal to k Ls plus y t raised to the power 2y. Now remember, any number is raised to the power 1. So we can have t raised to the power 1 equal to k Ls plus y t minus 2y. So to find the powers, which is x and y, we need to equate it to the left hand side. So here this is t raised to the power 1, t raised to the power 2y. So I can have what we call t raised to the power 1 equal to t raised to the power 2y. This t cancels this t. I have what we call 1 equal to minus 2y. Therefore, y is equal to minus 1 over 2. Then there's no L variable here, so it's 0. So I can have 0, let's say L raised to the power 0 equal to 0 here. There's no L variable here, so 0 is equal to x plus y. But remember, you'll be able to calculate for what we call y here. So x will be equal to 0 will be equal to x minus half. Therefore, x is equal to half. So rewriting this equation, we are going to have t equal to k L, and x here is half, j, and y here is also minus half. So here the equation will be t equal to k L raised to the power half multiplying g raised to the power minus half, and this can further be written as t equal to k square root of L over g. So the equation becomes t equal to k root L over g. Thank you for watching Tech 96. Please, if you are new to this channel, kindly subscribe and recommend to your friends. Thank you.